Good morning, everyone. This is Samuche Ajimai, the founder of Circuitwise Consults, and today in Circuitwise Academy, we are going to go over alternating current and direct current. And as promised last week, this is the second lesson that we are going to go through to understand or help us build circuits better. Okay, so last week we went through what electricity is, how it powers our modern world. We talked about voltage, we talked about current, we talked about resistance, and we even spoke about the Ohm's law together with some formulas. Okay, where we said the voltage is the potential difference across the negative and the positive terminal, which helps us to get electrons. We talked about the current being the flow of electrons through a conductor at a given time, and we spoke about resistance being the opposition to the flow of electrons at a given time. We stated the Ohm's law in its mathematical form as the voltage equals current times the resistance, where we said if you have two of these, you can always find the other using that law. Okay, so today we are going to delve deeper into the understanding of current, and we are going to talk about alternating and direct current. Okay, so a little refresher, as I was saying, that electric current is the flow of electric charge through a conductor. Okay, the conductor mediums is the material in which the electrons move through, like a wire, and this wire can be made of copper, iron, and all these various metals that have very good and high conductivity. Okay, and the flow patterns is really what we are going to talk about here. Okay, electric currents do not have the same pattern, and depending on the pattern of the flow, that's where we can say this is direct current or this is an alternating current. Okay, so we've been saying direct current, we've been saying alternating current. What is direct current? What is alternating current? So direct current refers to unidirectional flow of electric charges where electrons move steadily from the negative to the positive terminal. Okay, for direct current there is no change, there is no deviation. The electrons will move from the negative to the positive terminal until neutral equilibrium is reached, or until the source of the current is zero, okay, or has died out. Okay, the key characteristics of direct current is that the current, as I was saying, flows in just one direction. The voltage remains constant over the period of that flow and is produced by things such as batteries and solar cells, and is currently the source of power for our mobile phones, the laptops, and almost all the electronics that we use, AirPods, headsets. Like almost all these electronic devices are powered with direct current. Okay, and then we move on to alternating current. Alternating current, as opposed to direct current, is current that changes its polarity periodically. Okay, so the positive and the negative are constantly changing. So with that one, it's very difficult for you to say which one is the positive terminal, which one is the negative terminal, as these positive and negative terminals are constantly changing. So the electrons is moving to and fro, to and fro, and these changes can happen like 50 times in a second or 60 times in a second, depending on the country that you find yourself in. So in Ghana, our AC rate is like 230, 220 to 240, 220 to 240 volts at 50 hertz. Okay, so with ours, the polarity of our AC source is changing 50 times in a second. When you go to country like the US, they have 110 volts changing at 60 hertz per second. That's 60 times per second, which is 60 hertz. So 60 times per second, which is 60 hertz. And the main source of AC current is an AC generator, which is found in various power stations in the world. So with the countries that have hydroelectric stations like Ghana, our Kosombo Dam, we make use of these things. So when you go to the Akosombo Dam, there is a huge rotor with magnets in between, and then they have they have stored water at a certain height. Okay, water that has a lot of potential energy. So when you've seen the dam being opened before, when they open the dam, the waters will be coming down at very high pressures, These pressures will then cause the rotor to rotate in between two permanent magnets, okay, the north and south of two permanent magnets, and this rotation in the magnetic field of the magnets cause an induction which causes current to flow, okay, and this current, as it's flowing, the current flows out changing directions because of the placement of the brushes, okay. The placement of the brushes causes the current, or causes the electron flow to be changing in direction. This change in direction is what we refer to as AC current, okay. So there are some key differences between AC and DC that we are going to talk of. The first feature where we can notice some changes in is the direction. As we said, direct current moves in one direction and alternating current moves or changes periodically, okay. For voltage, we have a constant volt. So if an AC or if a DC current source is 5 volts, it's going to remain 5 volts. If it's 12 volts, it's going to remain 12 volts. If it is 15 volts, it's going to remain 15 volts. But for alternating current, we have the voltages changing. So if it's a 5 volt, or it has an amplitude of 5 volts, the 5 volts will be alternating between positive 5 volts and negative 5 volts, positive 5, negative 5, positive 5, negative 5. For the sources of DC current, we have the batteries, as stated earlier, we have the solar panels, and we also have the DC generators, okay. So now there are generators that can produce DC current, okay. For alternating current, we have the still old AC generators that can generate for us. As of now, we don't have any small pack AC or AC power source like we do for the batteries and the solar panels, okay. And for the transmission, good one, or someone may ask that if almost all the components that we use are currently DC powered, why are we still generating electricity in AC? And this is because of transmission, okay. DC is very difficult to transmit over a long period of time, as increasing the voltage of DC is way difficult than increasing the voltage for AC. So to transmit something over a long period of time, there are some factors that we consider, like the resistance, okay. Resistance tends to increase over length, okay. So even though the material might be might have a very small resistance, looking at the length, that resistance will compound, making the length across, or making the resistance across that length very high. Another key factor is also heat. As electricity is flowing through a given conductor, some of its energy, some of the electrical energy is lost through heat, okay. And this, because we can't really amplify DC current to a very high voltage to cater for these things, we opt for AC current. With the AC, we can use transformers to really step it up, to step these AC currents up a notch, okay, and then transmit them. And when we are getting to our destination, we step it down so that we can use it in our various homes and offices and all these things. So when they are transmitting it from the Akoso modem, they transmit it in orders of kilovolts, or like very high orders of voltages, okay. But when it gets to our socket, you realize that it's just 220 or 240 volts. That's because there's a step up and a step down transformer in between both ends to make sure that we get electricity in our homes, okay. So how does these things come up by? So Thomas Edison, even though we understood more about electricity, Thomas Edison is the one that's currently being credited for the discovery of DC current, okay. So he discovered DC current, he tested the DC current, he created light bulbs and all these things to show us the potential of DC current, okay. And there came the genius Nikola Tesla, who noticed the flaws of DC current, and one of the flaws is what I explained to you about the reliability of a long distance transmission. So Nikola Tesla saw this hindrance, or saw this downside to DC current, and decided to come up with a more powerful version for use in terms of transmission, so that everyone around the world would have access to electricity. So Nikola Tesla came up with the alternating current, and the alternating current became the standard for power distribution worldwide. Okay, so application today. So for application, DC application, we have AC application. Sorry, for AC, we have the household appliances like these heaters, these how do I put it? Currently, most of even the household appliances have some DC components in it, but yeah, so mostly some household appliances, industrial motor, these AC motors that we see in industries, and these power transmission. Okay, power transmission. These three are some of the key applications of AC today. And then for DCs, we already have our mobile phones, we have our LEDs, and we have the now famous electric vehicles due to Elon Musk and all these things. But you see, AC and DC work hand in hand in our current day. We don't have machines that totally or absolutely rely on AC, or not. I won't say there are some machines that actually only rely on either AC or DC, but if you find yourself in a setting like a home or an office, some of the devices will be DC powered, some of the devices might be AC powered. Okay, so we need to find our way, and the power that we are getting from the main source, which is the Akosombo Dam, the power that we are getting there is AC. So we need to find a way to make sure that the AC and the DC, they communicate, or we can change between them intermittently. Okay, so to change something from AC to DC, we are going to need a rectifier circuit. So the rectifier circuit will convert the AC to DC, and almost every one of us have used a rectifier circuit before. And to pinpoint that, just pick your phone charger. Okay, inside your phone charger is a rectifier circuit that converts the 220 volts from the AC plug to 5 volt DC for your phone. Your laptops, for instance, your laptop has an inbuilt rectifier circuit, not an inbuilt, like inside the charger. The charger has a rectifier circuit that converts the 220 volts AC from the main socket to 12 volts DC for your laptop at various level of amperage depending on the power consumption of your laptop. Okay, so, and also if you want to convert DC to AC, you are going to need something called an inverter. An inverter takes the DC current and then converts that DC current to an alternating current for use by AC systems. Okay, so these two can be used interchangeably, and depending on the application and what you are using your system for, you can decide whether to make use of an AC or a DC. So summary, we have both of them being essential for modern day life. As AC powers our infrastructure, it helps us in efficiently transmitting electricity to homes and cities. DC current also helps us run our devices, and actually both of them are complementary system that complements each other. As I was saying, we can switch between AC and then also DC, and then we can use them interchangeably. Okay, so I hope this lesson was truly inspiring, and I hope it's going to help us understand the in-depth or the things that goes on around our world. Okay, this is a practical lesson series that will help us understand these things better. Okay, so for next week we are going to talk about power and energy, understanding kilowatts, hour, and various power ratings in electronics. Okay, so there are a lot of things that goes into this that I didn't really go into details, and you can read more about it. This is supposed to be a practical thing. This is supposed to help us build practical electronics and not more about a theoretical aspect. Okay, so next week we'll be talking about power and energy, and please, if you have any comment, feel free to reach out, and then we would have a nice conversation. We can have a nice talk. So thank you so much again, and I will see you guys next week. Bye bye.